everyone. Good morning. My name is Anish. I'm the CEO and co-founder of Traversal. So let me begin with the problem. At the highest level, what we're trying to do is to help make software systems more reliable. And let me explain what the problem is and why this is something we should be thinking about. So if I think about the major categories of software engineering, which is where a lot of the work around foundational models and large language models have added value, I think of it as three parts, right? There's system design, there's development, and troubleshooting. So system design is where you're architecting a system, you're thinking about all of the ways you can build it, all of the trade-offs, it's creative, it's fun, so on and so forth. Development is where we think we spend the most amount of time, we actually build the system. And the third part of it is troubleshooting, which is when, invariably when you bring the system into production, it breaks, right? And when it breaks, you have to figure out how to fix it. Right? And if I think about the overall cycle, the software development life cycle, these are the three parts. You design it, you build it, and then you maintain it. Now, what is happening is that the biggest development we've probably seen with large language models has been in this area of software development. Right? We've seen the incredible developments from things like Cursor or Windsurf, Copilot, what have you. Right? And they've made that part, even now it's like 30% of code is being written by these systems. It's probably going to be somewhere like 80%, if I had to guess, by next year, something like that, right? And so this part around software development is shrinking, right? So what is the dream? What is the dream that we get sold when we hear things like software development is getting eaten up by AI? It's, right, what is going to happen to the other two workflows? That's what you have to think about. So the dream is that this is what will happen, right? We'll spend all of our time doing all of the fun stuff, which is if AI is writing our code and it's troubleshooting, then we get to focus on the creative parts about how do we actually design systems. We get to come up with PRDs. We get to think about what we want our system to do. We declare it, and it just magically happens, right? So that's what we hope will happen. I actually think to make that happen, to make that actually true, what we need is we need the troubleshooting part to be automated. Right? That's the part that needs to become automated if we want the system design part to be where we spend the majority of our time. Now, the problem is that I think this is the reality that we're going to live in. And I think it's going to be more and more the case over the coming year unless we do something about it. It's already happening. Now, in some ways, the best engineers we know, what they're doing is they're spending more of the time doing QA and troubleshooting. Right? And it's only going to become harder and harder over time. I think the reason is that because all of this code that used to be written by engineers is now being written by AI systems. So engineers have less context about what is actually happening in the code base. So they have less of it in their mind or in their cache to figure out how to actually fix it, right? Second, because we can write more code, we will write more code, right? Because we can now have AI systems write the majority of our code, we're just going to write more code. And so these systems are going to get more and more complex. Right, so if the systems get more complex and we have less context about what's happening, then troubleshooting is going to get even more time consuming. That's where we're going to spend all of our time, which seems like a cynical, sad way that we end up, right? Where we think we're going to do the most creative work, but eventually we actually do the least creative work for the majority of our time as engineers, which is, I'd say, an unfortunate conclusion if that's how it plays out. So why is this troubleshooting workflow so painful? What does it look like? What does it feel like right now? So what you have is essentially these great companies that we all know and love. So companies like Datadog, Dynatrace, Prometheus, Grafana, Elastic, what have you, right? And so all these companies, what they do is they essentially help you take all this data and they store it for you and they visualize it for you, right? So they're a mechanism to store and visualize data. And what you come out of from these different tools is these massive dashboards. You have this huge collection of dashboards that you have to look at to give you some sort of insight as to the health of your system, right? And you're paying these companies a pretty penny, right? It's typically around, it can be something like 20% of your cloud spend goes to your observability spend. So it's a huge cost center for a company. And what they really end up doing is visualizing your data. Now, let's say something happens. You'll have some sort of alert that pings. Some customers are facing an issue. When something breaks, typically everything is breaking in your system, right? So you'll see spikes happening all across your different system. Now, when that's happening, what tends to happen is you have engineers who are dashboard dumpster diving, which is you're going through all these different dashboards, trying to figure out which one explains what is happening, right? And the problem is because everything is pinging at the same time, figuring out which one is the right root cause is painful because most things you see are going to be symptoms of the issue versus the actual root cause. Right, so it typically takes, and the problem is that, especially at large enterprises, no one team has enough of the context, right? So you'll be searching through these things. You might find one sort of lead that you think is the promising lead. You're saying, okay, maybe that's really what caused it. You look at that lead, and then from there you try to figure out what is the change in the system that explained that spike, right? That's when begins the second part of this system, which you start aggressively staring at your change logs or your code base and saying, okay, is there some PR that explains what happened? Is there some change in my system that explains what happened? And most of the time you'll be like, no, that wasn't it. And then what you do is you get more people on call, right? Suddenly, when you started with 10 people in an instant war room, suddenly you'll have 50 people in an instant war room because you don't know which team actually is in charge of this issue. And this thing keeps going on and on and on, and it can take sometimes days to solve it, right? Typically, it takes like 1 or 2 hours, 50 engineers for major incidents. Sometimes it can take days to solve this, right? You can see why the system is so broken because of just the amount of information you have to look through. No specific team has enough of the context to figure it out, and that's what makes this problem painful. Okay? And this is a problem that's existed for decades, right? However long we've been running software, things have been breaking. And people have tried to solve this problem for a very, very long time. What's traditionally been called is AI ops, right? It's a space that people have been throwing a lot of money at for a long period of time, and it's been of okay return, to say it generously. And why doesn't it work? So if you try to have these traditional methods of AI ops, where you try to throw some sort of machine learning model to get some sort of representation of your data, the problem is these systems are too dynamic. They're changing all the time. They're too big. And so what happens is if you try to fit some sort of neural network model on your data, you'll end up with too many false positives, right? And so the worst thing you want when you have an incident is a lower signal to noise ratio, which is you're adding more false positives. People have more leads they have to look at, and this noise only makes them even more pissed off as to what's happening, right? So that's why these things never took off, because you have too many false positives. Okay, now let's look at let's try to think about what we could do in the world of large language models, at least in the obvious sense. The first thing is, why don't we just throw all of our logs and all of our metrics into an LLM and hope the LLM figures it out? The problem is it'll never fit in a context, right? It's not even a problem of context size. The data where we're dealing with is petabyte scale data, right? When you think about telemetry data at a large enterprise. So forget about context, it's not even going to fit in a memory, right? It's not even fit into a cluster. That's how large these data sets are. And so you have to be looking at this data sequentially, and that's why you need something like an agentic approach. Now you can ask the question, why don't I just build a React agent, right? That's what everyone does when they say they're building an agent. Let's just build a React agent and something good will happen. The problem is that if you want to build a React agent, you have to give some sort of meta workflow of what this agent has to do. It needs some sort of guiding principles. And the best we have towards that is runbooks, right? So I'm sure some of you who have been engineers have played with runbooks, and it typically is a meta step of steps you have to do. Like, let's look at this dashboard, correlated with these error logs, then connected with these changes. There's like a collection of deterministic steps you do, and you have to do some sort of semantic reasoning. And you can get an LLM to do that. That's great. But the problem is that most runbooks you have are always deprecated. So any sort of runbook style approach that you might be using is typically not going to be useful for large complex incidents. It might be useful for those routine alerts that you get pinged at every 5-10 minutes, but that's the type of stuff that no one looks at anyways. Those are the types of alert streams that no one's looking at anyways. Okay? So these kind of obvious approaches of AI ops, throw it in an LLM, or just build a React agent are never going to work. Right? That's at least my contention in this world. So what's our solution at Traversal? So here's the high-level diagram of how each of those pain points that we have can be solved by something that's happening, some developments that are happening technologically in this day and age. So this problem of dashboard dumpster diving, which is like hunting through your telemetry data to find the right particular set of symptoms that explain the issue, that instead of dashboard dumpster diving, you can have a swarm of AI agents, which is like thousands of these different agents working in parallel, looking through all the different hypotheses at the same time, and using something called causal machine learning, which is something I'm a researcher by training. And that's a field that I focused on, which is, so causal machine learning is the study of correlations and causation. How do you get these AI systems to pick up cause and effect relationships from data? That's what I studied. So if you mix this AI agent swarm approach with causal machine learning, that effectively helps you get to the promising lead, like the right lead very quickly. And then from there to figure out what is the right code, like piece of code that actually caused the issue, or change log that caused the issue, that's where these techniques of RAG or vector search, along with all the developments and code agents help you. And they can even help you fix the issue, right? And so then instead of having more and more teams show up all the time, you just have the right team coming with the right context. And so what we've seen with some of the enterprises we work with is rather than 50 people in an instant war room, you'll have something like 10 or 15 with just the right context to deal with the issue at the right time. right? So this is, in some sense, the big pain points that we think we can solve with all the developments that we've done at Traversal. And so what is it that we're doing differently? I think of it as three things that actually make this work now and which couldn't have worked even 6 months ago. So the three things are you need to combine the best of statistics and semantics. So you need to be able to filter your data statistically, and that's why causal machine learning shows up. You need to use semantic ideas. Like you need to have a system that can actually parse what is in the log message, parse what is in the metadata of a metric. And that's where the reasoning models are really good. We've seen all the developments with inference time compute, with O3, with Sonnet. That's really helped in terms of actually getting the deduction to work. And you need to have a novel agentic control flow. And I think the best word we can call it is a swarm of agents, which is, I think of almost as agentic MapReduce, where all these different agents are working in parallel, and they kind of combine that information and then go and work in parallel again. And that kind of approach or control flow is really what brings it all together. Right? So when you combine these three things, which is causal machine learning, reasoning models, and swarms of agents, that's really what makes this work in a way that just couldn't work even 6 months ago. Okay, and I'll say that to make this problem work, it's one of the hardest research problems I've worked on, and it requires actually being at the forefront of what these of research, both from a statistical sense, from the causal machine learning sense, and also from the agentic architectures. And see some of the papers that we've written at Traversal before our time at Traversal or during our time at Traversal. And then I'll say that our goal really is to think about revolutionizing software reliability as a whole. And if I think about what software reliability is, I think there's really 5 parts to it. The first part is alerting, which is actually detecting that an issue is happening. Right? The second part of it is root cause analysis, which is actually hunting through the telemetry data to find that specific log or metric that explains what happened. The third is remediation, which is to actually fix the issue. Right? Either when you found the specific change that caused the issue, can you now fix it? So fixing the issue. After that, doing a post-mortem, so the system learns how to be more reliable the next time. And then the next time is actually doing a preventative measure, right? So something that prevents this issue from happening the next time. So where we have been squarely focused over the last year has been the root cause analysis remediation part. And over time, we hope to get into all of it. The one way I think about it is that this problem of software reliability is about finding this needle in a haystack, right? Which is, can you start, and in some ways the goal is, can you make the haystack bigger and make the needle smaller? And so right now, this is where we're starting, but over time, we just want to make the needle smaller and smaller and make the haystack bigger and bigger. And that's, and in short, that means dealing with the alerting, preventative measures, and postmortems. Okay. So some case studies of what we have done. Probably one customer that has allowed us to speak publicly about our work with them has been DigitalOcean. We've worked with them over the last 6 months. So they're a public cloud service provider, and they have 600,000 customers that rely on them as their public cloud. And so as you can imagine, if you're a cloud provider for customers, you're mission critical, right? If you go down, every customer that you have is going to complain because they rely on you to power their actual systems. And over the last 6 months, we've seen that we've reduced their time to resolution by 38%. And this is a very complex infrastructure problem because they have one of the most complex engineering outfits you can imagine as a cloud provider. And so it's in GA across the entire engineering org. And we found that over the, we've carefully gone through every incident that they've had. And we found that of the 82% of them have been scope, and out of that we had 84% accuracy. Okay, so results have been very promising, and they're improving every day. I'm going to skip the demo. It's going to be on the website, given time. And I'll just say that what we've designed for is actually large enterprises. That's what we've found to have the most value. A few things happen once you become an enterprise scale customer. One is your data is actually very mature. Typically, all of the instrumentation you need to deal with, to debug an issue is present. Right? When you're a smaller company, sometimes your instrumentation is not yet in place. At the same time, when you get very large, your data gets fragmented. You have many teams, you have many different data sources you're using, and correlating across them is really what's the pain is, both from a team perspective and software perspective. So some of the companies we work with, let's say this financial company that we're in production with, they have over 1 trillion logs, 100 billion metrics, and just a huge number of different services they use, such as OpenSearch, Dynatrace, ServiceNow, GitHub, I mean, just a ton of different services. And it's correlating across these fragmented data sources where the pain really is. And across them, we've been able to find the root cause in less than 5 minutes. And I'll say that this problem is just as much an infrastructure problem as it's an AI problem, right? Because you have to get these systems to actually work and give you back an answer, search the space and give you back an answer in less than 5 minutes. And so being able to search the space very efficiently is an incredibly challenging infrastructure problem and AI problem at the same time. And I'll just note that as we think about AI agents and building AI agents, to me, they're all about automating workflows that we do on software. And in some ways, whether we realize it or not, one of the biggest workflows we do is about what I call finding a needle in a haystack, right? Which is where you start with some high-level trigger, and you need to figure out what caused that trigger to go off. That same thing happens, obviously, in observability, as we talked about. It also happens in security. It happens in networking. It happens in product analytics. Even happens in BizOps, right? All of these places, you start with some dashboard that you care about. Some spike happens. You're trying to figure out which other spike caused that spike to happen. Right? And so if you can automate this workflow of finding a needle in a haystack, it has implications across many different industries. And so I think it's a problem that a lot of us should be working on. And I'll just end quickly with what our team is. So this is the co-founders. So 3 of us met at MIT where we were doing our PhDs. And I think we just felt that a lot of the incredible research developments that are happening in this day and age are happening just as much in startups as they're happening in universities, which is why it prompted us to create this company. And our 4th co-founder, Ahmed, he's from Citadel Securities, which is where, as you can imagine, downtime really, really matters there. And so we found that the collection of us were the right people to take on this problem. And in some ways, the team we've brought together has been the right collection of people to solve this problem. It comes from 4 different worlds. So I think we have like 7 people from Citadel Securities at the company, a bunch of people from dev tool companies such as Datadog, ServiceNow, Cockroach Labs, et cetera. A lot of AI product engineers from companies like Perplexity, Meta, Glean, Hebbia, and researchers from the top universities. And I think you have, in modern companies that are really trying to push the limits of what it means of AI agents and building a world-class team that solves the hardest problems, you have to kind of have people from all of these 4 different areas together to actually solve the problem. So I think as you think about building a team, think about what is the right composition, because if you have the right composition, everything else will flow. That's all of us. We're all in person in New York City. We're hiring. So if it's of interest to you, please send us a note. Thank you very much.